while back I made video on combined transformations, and they were the basic transformations. This is a more advanced set of videos on it. So we're going to take our three generalized stretch, our rotation and reflection matrices, and we're going to apply them in a combined way. The first video we're going to look at what happens if I apply two of the same type of transformation, and then in the second video we're going to look at what happens if I can apply combinations of reflections and rotations. Okay, before we move on, we've got to be very clear what happens when we apply transformations. I take a point as my vector x, and I apply in my first transformation matrix 1, and I get my image x dash. And then I want to apply a second transformation to it. So I start with my x dash, I apply my M2 matrix to it, and I end up with my final image x double dash. So what does that tell me? Well, it tells me that all my maths is working that way, isn't it? We need to remember that because people get it wrong. So I start with my point, I apply my first matrix on the right hand side, and then my second matrix on the left hand side. So I'm moving, working right to left. Okay, let's look at simple one first. I've got two stretches. Here's my first stretch. It's got a scale factor x in the x direction of 1. It's got a scale factor in the y direction 1. The little ones tell us which matrix we're in. This has got scale factor in the x direction 2 and scale factor in the y direction 2. What happens when I multiply them together? Well, when I multiply these matrices, I end up multiplying my two scale factors here for the top left, and I multiply two zeros, don't I? So my top left becomes the two scale factors in the x direction multiplied together. If I look in the bottom right, I get my 0 times 0, and then I get my scale factor times scale factor in the y direction. There we go, that's good. What happens in the other directions, in the other corners? Top right, well, I've got a scale factor times 0 and a 0 times a scale factor, so I end up with a 0 there, and you can imagine same thing happens here. Bottom left, 0 times a scale factor, and I've got scale factor times a 0, so I get a 0, 0. So what sort of matrix am I looking at the end? Well, that's a stretch matrix still, isn't it? And what is the stretch? Well, in the x direction, it's got the product of the scale factors in the x direction, and in the y direction it's also a stretch, and it's got the product of the scale factors in the y direction, which all makes sense, doesn't it? If I do a stretch and I do another stretch, then I'm effectively going to multiply up the scale factors. Okay, what happens with a rotation? You probably think that this is more straightforward. A rotation and a rotation are going to combine. Yeah. So here's my rotation 1, it's going through angle theta 1. Here's rotation 2 going through theta 2. I'm applying them from the right to the left. So I write the R1 on the right and R2 on the left. If I multiply these together, let's look at top left. I've got a cos, and then I've got a negative sine. There you go, that's that one, which you'll recognize from compound angles is the cos of the two angles added. So that's an addition. And if you think about it, same thing happens in the bottom right. So look, I've got a sine, but that's negative, and I've got a cos, so it is positive, so I've got exactly the same expression. So these two are both the causes of the combined angle. What's happening in the other two corners? This is important because this will tell us what sort of operation we're looking at afterwards. Well, let's have a look at top left. So top right, so I'm going to get a cos times a sine, that's negative. I've got a sine times a cos, that's negative. So both of these are negatives, aren't they? And if I took the negative out the front, you would know that sine cos plus cos sine is the addition of those two. And if you think about the bottom right, what's that? Bottom left, sorry, I'm getting a sine times a cos, and I'm getting a cos times a sine. This time they're both positive. So these are exactly the same expressions, except one's negative and one's positive. So I'm going to make that's the positive sign. There we go. So looking at this matrix I've now got here, not surprisingly, all the angles, compound angles here are the same at theta, And in order to know whether it's a rotation or reflection, I just need to see where the negative sign is. In this case, the negative sign's in top right, so that means it's a rotation. That's what we'd expect, isn't it? Applying a rotation to another rotation, we're just going to get the combined rotation of θ1 plus θ2. That's what we'd expect. Okay, let's have a look at reflection example. So reflection 1 has phi1 as the angle, and reflection 2 has phi2 as the angle. Put them in here in the right order, working right to left. And now let's start multiplying these out and getting our combined single matrix. So what have I got? I've got a cos plus a sin top right, top left, sorry. What's happening bottom right? Well, here I've got a sin, and I've got a negative cos, which is going to become positive. So these two corners, top left, bottom right, have got the same expression in, and we know that from compound angles, if this angle's positive, so the sign's positive in the middle, we're doing the difference. So here I've got the cos of the difference of the two angles. So I've written it as phi2 minus phi1. Sometimes you'll see this with a modulus sign there because it doesn't really matter which way round they are because of the symmetries of cos. And bottom right's going to be exactly the same, isn't it? So we've sorted out top left, bottom right. Now we need to have a look at what's happening here in the other two corners. So let's have a look for top right. So I've got my cos times my sine, and I've got a negative. So I've got sine times a negative cos, which you'll probably recognize that I've got a sine cos combination. So with a negative sign in the middle. So I'm going to have the difference again between the two angles. That makes sense, doesn't it? And if I look in the bottom left, well, I had a sine cos, take away a cos sine. When you have a look at it, it's the same expression, but the sign's different, isn't it? So if I want to be consistent here, and I'm going to use this angle here, then there's the difference angle inside the bracket. Then moving down from there to there, you'll see that this one is going to be exactly the same angle, and this one, this top right expression, is going to be the negative of that same angle, and we know the bottom right was the same cos. So there we have the same angle in each of the brackets here for our sine and cos. What tells us whether it's a rotation or reflection? We have to look, see where the sine is, and the sine's in the top right. And if the sine's in the top right, we're looking at a rotation matrix, and we're looking at a rotation matrix with the rotation is whatever's inside the bracket, which is two lots of the difference. Sometimes you'll see that written as the modulus of the difference, two lots of the difference. So there you have it. We have a reflection, and a reflection resulted in a rotation. Some of you might have thought about this in the past, because if you remember when we rotate, so we reflect in the x angle and then the y angle, we end up with a 180 rotation. So let's just check that out. If I'm rotating on one of these, one of them's going to be 0, the other one's going to be 90 degrees, isn't it? For my two lines, there's one going that way and one going that way. Difference is therefore 90 minus 0 is 90, and we're doing two lots of that is 90 is 180. So we're seeing that if we reflected in the two axes, we're going to end up with the same as a rotation of 180. So here we go. We've just covered the top part of this for now. We'll come on to the second part. So a stretch and a stretch results in another stretch, and all we're doing is multiplying the scale factors. A rotation and a rotation results in a combined rotation, and the angles are added. And the one that's a bit odd is a reflection, and a reflection results in a rotation, and the angle is twice the difference of those two angles. So there you have it. That's the first video. I'll come on and pick up the second in a sec.